In this video, we're going to be looking at solving linear equations. Now, we're going to look at particular forms of these equations, and they're generally speaking the simplest forms. So ax equals b, x over a equals b, or ax over b equals c. So three different formats, all very closely linked together. The important thing is, when we're solving equations, is that we show all our workings. The reason being that as equations get more complicated, the methods stay the same. And if we can use it, we can apply it to other situations, and it makes life much easier for us later on. So the first one we look at is the type 1, which is ax equals b. And the best way of doing this is by example. So if you look, the question is going to be, solve 3x equals 45. This means that we've got to find the value of x that's going to satisfy this equation, that's going to make the statement correct. So we start off by writing out the question, 3x equals 45. And the trick is going to be here that we're actually going to divide both sides by 3. Now the reasoning for that one is that 3x means 3 times x, or x times 3. And the inverse of timesing by 3 is dividing by 3. Hence we divided both sides by 3. Now when I do that, 3x divided by 3 is x. We want to be left with x on its own. 45 divided by 3 is 15. So second example, similar situation. 7x equals 16. So the scenario here is, write out the question. We're going to divide both sides this side by 7 because we want x to be left on its own. So x is equal to 16 over 7. Now this time we can't simplify this, so we're going to leave it as an improper fraction. Example 3. So this time we're going to introduce negative values into this. So negative 4x equals 13. Now the trick here, to make this as easy as possible, write out the question, and I would recommend you change the signs. We always want the x's to be positive if we can. So by changing the signs, we change the sign in every term. So negative 4x equals 13 becomes 4x equals negative 13. Now we divide both sides by 4. And we get x equals negative 13 over 4. An improper fraction, I can't simplify it any further, so I'm going to leave it like that. Example 4. This time, the equation has been written the other way around. So 20 equals 6x. But we do the same thing. We still divide by 6. We divide by the number of x's to get x left on its own. We're left with 20 over 6, which can be simplified to become 10 over 3. So x equals 10 over 3. In effect, what we're doing is we're working backwards. If you prefer, you could have written the question the other way around. So instead of writing 20 equals 6x, you could have written 6x equals 20 and solved it like we did previously. Now we look at a second type. So this type of expression is going to be x over a equals b. So we've got x over 5 equals 7. Now remember, x over 5 means x divided by 5. And the inverse of dividing by 5 is timesing by 5. So this time, we're going to multiply both sides by 5. So we write out our question. We times both sides by 5. And we're simply left with x equals 35. Okay, remembering that divided by 5 and times by 5 are the opposites of each other, so we'll cancel each other out. So this time we're bringing negatives into it. So negative x divided by 3 equals 10. Again, as before, change the sign. So x over 3 equals negative 10. Now you notice one term is the x over 3 part. That is one term. So we don't change the 3 to become negative in there. Now we multiply both sides by 3 and we get x equals negative 30. Example 3. This time the other way round. Solve negative 7 equals negative x over 4. Okay, write out the question. As before, we're going to change the signs of every term. So 7 equals x over 4. Multiply both sides by 4 and we're going to get 28 is equal to x, or x equals 28. The last section is when we use a combination of both types. So for example, this time we're going to solve 3x over 4 equals 11. The easiest thing to do here is to first of all to get rid of the fraction, multiplying both sides by 4. So we just multiply by the denominator of the fraction. So that leaves us with 3x is equal to 44. Now, as before, we divide both sides by 3 and we're left with x equals 44 over 3. An improper fraction, I can't do anything better with that one. Another example. So 2x over 7 is equal to 4. As before, get rid of the fraction. So to do that, we'd multiply both sides by 7. And notice how I'm showing all my workings here. So 2x equals 28. Now I divide both sides by 2, so x equals 14. Whatever I do to one side of the equation, I must do to the other side. Okay, negatives in that, same as before. So we write out the question. Again, we want to deal with our negatives here, so we're going to change the sign of everything. I want the x's to be positive, so that gives me 5x over 8 equals negative 2. Now we get rid of the fraction, so multiply by 8, so 5x equals negative 16, and then we're going to divide by 5, so x is equal to negative 16 over 5. And again, I'm happy with the answer as an improper fraction. The last scenario that we're going to have is if we're working it the other way around. So negative 13 equals 3x over 4. Now notice with this question, the x is positive. There's no minus sign with that one, so we don't need to change signs. We're just going to get rid of the fraction here. So multiply both sides by 4. So negative 52 equals 3x. Divide both sides by 3. So negative 52 over 3 equals x.